Hello viewers, welcome back to class. I'm super excited to welcome you guys back to class again. You are welcome to Master Builders Online Academy. So if you are new in this channel, do consider subscribing to our channel and ensure that you turn on the post notification bell for more exciting videos. Guys, we have been looking at calculus. We've looked at differentiation of function in calculus. We have looked at limits of functions in calculus. Now, in this lesson, we shall be looking at integration of functions in calculus for undergraduate students who offers CBT in their examination. All right. So now, listen carefully. Do not skip any part of this video. This is for your own advantage. And also, anytime you are set to learn new concepts from this platform, ensure you avoid every unnecessary distraction. And finally, if there be any part in this video that you do not understand, maybe when you watch it for the very first time, guys, you stand the singular opportunity to replay the video over and over again until you understand it. And if at any point you do not understand when you have watched it over and over again, guys, don't hesitate to slide down to the comment section and ask your question. We will reply, we will give answers to your questions either individually or in groups. So, guys, let's get to the business of the day. Now we have integration of function above, and this happens to be the reverse of differentiation. Of course, when we started, we mentioned that differentiation is obtaining or finding the derivatives of functions. So we find the y by the s, it is the rate of change. Integration is also the rate of change, but it is the reverse of differentiation. So in differentiation, you reduce the power of polynomial function by 1, but in integration, you increase the power of the exponential by 1. Now, in differentiation, you multiply the coefficient of the variable by the existing power, but in integration, you divide the variable by the new power. So you discover that in differentiation, you multiply and reduce the power, but in integration, you divide and increase the power. So these are the things that you really need to do and you really need to understand as far as integration is concerned. So the same way we were differentiating different kinds of functions. Similarly, we are going to be integrating the different kinds of mathematical functions that we mentioned in our previous lesson. Of course, we said that in mathematics, we have numerous of functions. For instance, we have linear function, we have quadratic functions, we have polynomial functions, we have trig functions, we have exponential functions, we have logarithmic functions, and so many other functions that we have in mathematics. So we understand that in integration, we are going to be integrating these different forms of functions. And of course, we can integrate a simple function or a compound function. When I mean a simple function, that means when you are dealing with only one type of function. Now, for compound or complex function, when you integrate complex function, it means that you are integrating multiple functions, which can be 2 or more functions, either of the same family or of different family. Of course, when I mention family, you should understand that I'm talking about the kinds of functions. So the two product or the two quotient or the relationship between these functions also matters to us. Why we integrate these functions. So when 2 or more functions comes together in integration, it is either they come together by addition, by subtraction, by multiplication, or by division. So if they come together or they are related by any of these 4 signs, they have their respective rules that they obey. So we have integration of function of a function, we have integration of polynomial functions, we have integration of parts, we have integration by part, we have integration of partial fraction, we have integration by substitution. So we have different kinds of integration that we are going to be looking at in this lesson, and understand that based on the fact that this is for year 1 students, we are going to be using shortcuts so that you will be able to meet up with your exam duration. So, guys, do not skip any part of this video and ensure that you share this video. Make your friends and classmates get to know about this platform. Now, guys, if this is understood, we can start from the very starting point. Now, listen, guys. In this lesson, we will start from standard integral. Of course, in integration, the general notation to indicate that you are integrating any particular function is what we have at. So this is what we call integral that we make use of in integration. This is what we call integral. So when we have this as an integral, all we need to do is, if this is f of x dx, so if I have y is equal to f of x dx, this is how the integration. If I have y is equal to f of x dx, integral of f of x dx, this is how integration functions comes. So any question you have in the integration will always come in this format, where f of x can be any function of x. So we only integrate the right hand side of the equation with respect to x. So f of x can be any of the mathematical functions that we have mentioned in our previous lesson. So you need to understand that when you are given a function or you are given integration question, you must identify the function that you are given. This is what will help you to differentiate that function very well, because the way you differentiate polynomial function is different from the way you differentiate exponential function and different from the way you differentiate trig function. Similarly, the way you integrate polynomial functions is quite different from the way you integrate exponential function, trig function, or hyperbolic function. So in this lesson now, let's quickly start from standard integral. Very, very important. So at this point, if you have not subscribed to this YouTube channel, guys, consider subscribing to this YouTube channel and like this video, share this video, and make your necessary comment. Now, guys, let's see in the next lesson. So now, guys, on the board we have standard integrals. All right. So we are quickly going to run through this analysis. Now, when you integrate polynomial function, which is x raised to the power of n, all you simply have is x raised to the power of n plus 1 all over n plus 1 is equals. Then when you differentiate exponent x, you have exponent x. When you integrate exponent x, you have exponent x. When you integrate exponent ax, that is to say the power of the exponential function is more or less than 1. It can be a positive value or a negative value, but not 1. So what you do is to differentiate this. The result today would have given us 1 over a exponent ax, then plus c plus c plus c. We understand that anytime you integrate a function, you must add a constant, which we call arbitrary constant. Now, when you integrate sign, you have negative cos. And when you integrate cos, you have positive sign. We said earlier that this is the reverse of in differentiation. Differentiation increases coefficient, but integration reduces the coefficient. Are you there? Now, when you integrate sec square x, you have tan x. Just the same way, when you differentiate tan x, you have this. When you differentiate sin x, you have this. And when you differentiate cos x, you have negative sign. This is what we have here. So when I integrate this, I have ax ln a. Then equally, when you integrate sin x, you have cos x. Now, when we integrate cos x, we have sin x. Okay, now when you integrate 1 over x, you have ln x or ln x base e. So anytime you integrate 1 over x with respect to x, you have this. If I integrate 1 over u with respect to u, I have ln u. If I integrate 1 over w with respect to w, I have ln w. Then also, when I integrate ax plus c all raised to the power of n, this is a function of a function. All I need to do is to differentiate into, then I have 1 over a n plus 1 all into ax plus c n plus 1. This is so you increase the power by 1 and now divide everything by the power and the coefficient of the variable you have when you differentiate the function. Likewise, if you differentiate this, you will have this as. If you integrate 1 over, this is division. I have a numerator, I have a denominator. So when you integrate a function like this, we have k over a ln of the denominator, ax plus c. So you get to know all of these things in details when we start solving problems. Now when you integrate sine ax plus c, now it can also be sine ax only. They are all the same. This is constant. All I need to do is to differentiate the function of x, which would have given us a. I will have 1 over a. And when you integrate sine, you have negative cos. So this would have given us negative cos ax plus or minus c. Then when I integrate cos ax plus or minus c, I will equally have 1 over a sine ax plus or minus c. It can be plus, it can be minus. Whether you have plus connecting ax to c or negative connecting, you will have this as your answer. So if you were given positive, you will have only positive sign there. If you were given negative, equally you will have only negative sign there. Now when we come to this end, when you integrate sec squared, you know that you have tan squared. Now this, when you differentiate this function, you have 1 over a tan ax plus or minus c. Then when you integrate exponential ax plus c, it's not different from question 3. You are going to differentiate this power, and when you differentiate this power, you have 1 over a exponent ax plus c. All you need to do anytime you differentiate any function in integration, you will always take it as the reciprocal, 1 over whatever you have when you differentiated the function of x. Very, very important. You must take it as a reciprocal. Then when you integrate 1 over the square root of 1 minus x, you will have, and when you integrate this guy, you will have sine x plus c. When you integrate this guy, you will have cos x plus c. When you integrate this guy, you will have tan x plus c. And when you integrate this guy, you will have 1 over r tan inverse of x over r plus c. This is when you integrate. So we are going to be making use of all of this while we progress in this lesson. But the essence of this standard table is to help you familiarize yourself, is to help you what? Get the basic standard integrals that can possibly be of aid when you are writing exams. And these standards will also help you to understand the shortcuts very, very well. Because while we are taking this course, of course, as we know, we are using shortcuts. So with the help of this standard table, you will be able to act. You will be able to solve problems effectively using shortcuts based on the knowledge you have gained here. So before you digress to the next lesson, you must ensure that you get yourself familiar with this table very, very well, because a question you can be given a function as integrate exponent 3x. You don't need to crack your brain. You don't need to take biro and solve. All you need to do, if you can remember this, then you can get the answer. Just become 1 over the coefficient of x, then you repeat the exponential function. You see how it works. So ensure that you get to understand everything that we have here. Memorize the one you can memorize, understand the one you will understand, and then you can dive to the next lesson. Now, guys, if at this point you have not subscribed to this YouTube channel, do consider subscribing to this YouTube channel and ensure you turn on the post notification bell for more exciting videos. So guys, like I do always explain before now, when you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. So I urge you to get to understand the principles that work here while we solve problems. We may not be able to solve thousands of problems, but with the little problems we will solve together here, you will be able to solve thousands of problems on your own when you get the idea, because all the problems are solved in the same way. All you just need to do is to understand the concepts. So guys, don't hesitate to check the description below where you will find a link to the next lesson. Thank you for watching. See you in